All right, so for this one, we have to look up the Ka value, and I've kind of already got it pulled up over here. Here's the chart, and so you want to kind of scroll. This one is HCN, so it's like right in there. It's HCN, and so that number is going to be 4.9 times 10 to the minus 10th. That's going to be the Ka value. So Ka equals. So now I'm going to do my ice chart, ICE. My HCN, it says is 0.200. The water never matters, 0 and 0. Well, it's not that it doesn't matter, but it just doesn't go in our equation. So that becomes 0.200 minus x, and x. And so then I just plug that in. It's going to be x squared, because it's x times x, over 0.200 minus x. And I'm just going to plug in, let's see. Oh, I'm figuring out the percent ionization. So I'm going to go ahead and use my assumption method, because that's a really, really tiny exponent. That's like 9 zeros in that compared to the 0.2 number. So it's probably going to be just fine to call that x squared over 0.200 equals 4.9 times 10 to the minus 10th. I'm going to pull over my calculator, and I'm going to say 0.200 times, because it's just like you just multiply both sides by 0.2. So that number times 4.9 e to the negative 10th. And I'm going to take the square root of that. So second answer. So that gives me what my x value is. So my x is 9.89, or more specifically, it looks like it's going to be 9.99. 9.9 times 10 to the minus 6. But it's not asking me to solve for x. It's asking me to solve for the percent ionization, which is the x number divided by the 0.2. And it's great because I've already got it in my calculator. So x, it's basically x over initial times 100%. So it's that number divided by the 0.200 times 100%. Gets me not even into any kind of normal range. So my percent is 0.0495. That's if I needed 3 sig figs. And it looks like my Ka, I think, might limit it. The one that I grabbed had 2 sig figs. So if I go with that one, then that's going to be 0.0050. And we'll tell you how many sig figs you need.